thanks very much everyone for joining us. Thank you also to those who are connected remotely. I'm going to start off by giving a brief introduction and then handing over to Diane. Diane Dowejko joined the Center of Excellence in November last year, so she's only been with us for a few months. She's the research administrator in the Center of Excellence. She's specifically focused on science communication and digital media platforms. She obtained her MA in English from the University of Cambridge in 2013, and her more recent research focuses on literacy interventions in South Africa and legitimation code theory and CAPS documentation. So today she'll be presenting her work on engaging with various audiences through science communication. And this is something we feel is really important for postgraduate students and postdoctoral fellows to know about, which is why it's a really good thing that I see lots of you here. More and more, as you start applying for grants, you'll realize that the NRF and other government funding agencies see these type of what we call soft skills as being really critical in development of early research development in academia. So we think these skills are very important. Thank you very much, Diane, for taking us through this, and over to you.
Okay. Good morning, everyone, and thank you again for being here today and our online viewers. As Kaz mentioned, I'm the Research Administrator for the Centre of Excellence in Maths and Stats. Just to give you an idea of my portfolio, the kind of work that I do includes science communication and engagement. If that doesn't ring any bells yet, I am going to go through it, so that's the main aim today. Social media, web content, events organisation, marketing and public relations, and it's in this capacity that I'm presenting today. So just as an introduction, a basic overview of what I'll be going through today starts with what. So essentially, today's presentation will be a mixture of empirical evidence, theory and suggestions, and digital media related to science communication and engagement. So we're going to start with what is science communication. I'm going to engage in some definitions for us. The second question I'm going to hopefully answer is, why is it important and what benefits does it hold? Okay, for researchers, for scientists, as well as for the public. And how do we engage with various publics in a meaningful and engaging way? So here's where I'm going to look at some empirical evidence and the various platforms that we can use to do this. Okay. I think a really important start is defining what is science communication. So I want to just start by, by using a definition from Weingart et al., who have published this book, Science Communication in South Africa. According to Weingart, the dissemination of information is taking on new forms, and the public engagement needs to evolve along with these forms of science and technology. Okay? This dissemination of information, we need to redefine it as communication. Okay? In this sense, it takes on the form of a two-way dialogue. That dialogue is between science experts and researchers and the publics that they have the option of engaging with. I will talk a little bit about the publics in a moment and what that means. Okay. At every level, it's important to, from an individual level to science departments to institutions, it's important to have some form of science communication strategy, no matter how informal or formal it might be. Okay. Ideally, the strategy would be low cost, something which I'm sure we can all get on board with. Okay. Long term, so we want to be able to look at a view for future projects, which again I'll talk about in a little bit. Most importantly, we want it to be high on the return of investment. So what this means, according to Tankersley, what they define as return on investment, the forms that it would take, is the transfer of information, that dialogue, skills evaluation, new training practices, and very, very importantly, creating new communities of practitioners within science. So I said I'd get to the publics and stakeholders. So who are we talking about? Obviously, firstly and foremost, our public would be science experts or your peers. Okay, engaging with them. School pupils and parents, very importantly, and educators. So educators on any level from foundation phase up to higher education phase. Interestingly, another public for scientists is industry. Think to yourself for a moment, does anything that you've ever read in terms of research have an impact on the industry? And the answer is probably yes. We'll talk a little bit more about industry in a moment. Obviously, students are considered a public or an audience. We're talking about both undergrad and postgraduate students here, as well as, I haven't put it in there, as well as postdoctoral. And then what's very loosely defined as the general public. So basically anyone who is not within those other five would be considered the general public, but usually people fall into one of those categories in some way or another. What's very important that I'd like to note here is the type of science communication or engagements that you partake in will depend very much on your target audience. Okay. So who are you presenting to? Who are you engaging with? When we look at the methods for science engagement, we'll look a little bit more at how we engage with these various audiences. All right. Moving on, I'd like to talk a little bit about why do we communicate science. Okay. And there's a lovely quote there from Sir Mark Walford that science isn't finished until it's communicated in some way. And please note that he doesn't say disseminated, that he uses the word communicated. What I'd like to look at in this section is a few things. First of all, what are the qualities of science that we are talking about when we talk about communication and engagements? Very importantly, what are the benefits to us as researchers and scientists? We want to get something out of this. Okay. We're going to look a little bit at the importance of science literacy, and then we're also going to look at the challenges to science communication, because nothing exists without challenges. So I think it's important to look at the challenges in order to know how to overcome them or overwork them. So to start us off, in terms of the qualities of science, I think it's important to remember how full of quality science is, in whatever form it takes. Science is impactful. Science is making differences in lives every day. Across decades, across centuries, science makes a difference. Science is controversial. I'm sure we can all think of an example of that. Okay. And this is another quality that makes science newsworthy or communicable. Science is new. People are always coming up with new things. And these new things are often surprising. Okay. We want to see how we can engage with audiences with this surprising quality of science. Science is prominent. It stands out. It's very important. And it's topical. We can relate science, and we're going to look at some examples later. We can relate science to things that are happening in the world, and it's also proximal. So not just in the world, we can relate science to things that are happening in our proximity. So things that are happening in South Africa, in Johannesburg, in the university. Okay. And we want to look at how can we get other people to engage with these by using these qualities. Moving on, what are the benefits to you, to us as researchers? Okay, first of all, does this look familiar to anyone? Policies. Government-funded research needs to meet certain mandates in order to ensure continued funding. Recent mandates, several of the recent mandates now include some form of science engagement or communication. An example is the recent White Paper. It was published by the DSI last year, and I'm going to look at that in a little bit more detail to show you examples of how these policies are promoting science communication. Okay. Research, I'm sure we can all agree, is very competitive. Science communication promotes us as individual researchers. It also helps us to develop soft skills. soft skills such as presenting, what I'm doing right now, writing for various audiences, for example. Please note that I say various audiences. It also contributes heavily to your CV. Okay, so if people have seen that you've engaged in some way, it really bulks up your CV. As well, so what also bulks up your profile is constructing an online profile. Okay? This could be using social media sites, or even sites like Orchid. They aid us in obtaining further research opportunities and further funding, and make us prominent as researchers. Okay. I just mentioned policies. I want to talk a little bit about the DS5 White Paper. So this was published in March last year, and I want to highlight some of the policies that came out of this to give you the examples of the intent that was outlined. The first one is they want to brand South Africa as an innovative country. This comes back to us talking about science as proximal and relevance within our own country. Very importantly, we want to adopt a whole of society approach to innovation. Think about those publics that I talked about earlier. Whole of society. How do we engage with all these various publics in order to meet this policy? Increasing the spatial footprints of innovation. How can we reach into interdisciplinarity, looking at going not just from science, but going into human sciences or health sciences? How can we create bridges across that to increase the field of innovation in South Africa? Grassroots innovation, so starting from the bottom up, and social innovation. Again, going back to those publics, looking at school children, educators, your general publics. And finally, supporting a science literate and science-aware society. Okay. Science literacy is quite a prominent theme within science engagements and science communication. A lot of people see science literacy as one of the aims or outcomes. And I'm going to spend just a little bit of time now defining science literacy for you. My aim here, by defining it, is to hopefully get us to see how universal the concept of science literacy is, and how important it is even for everyday people who are not scientists. So to start with is the knowledge and understanding of scientific concepts. These concepts are required for things like personal decision making, okay? Participation in cultural affairs and economic productivity, things that we all have in common, whether we're scientists or not. Scientific literacy means that people can ask, find, or determine answers to questions that are derived from curiosity, everyday experiences, which create curiosities, require some elements of science literacy to enable us to answer them. Science literacy means that a person is able to describe, explain, and predict natural phenomena. Okay, something that everyone wants to be able to do. It entails being able to read, with understanding, articles about science in the popular press, so not necessarily academic articles, and engage in a social conversation about the validity of the conclusions. Okay, we want everyday people to be questioning us as scientists, to be asking questions and challenging us as researchers. Scientific literacy also implies that a person can identify scientific issues that are underlying national and local decisions and express positions that they are informed by scientific that are informed by science and technology as well. So we're talking about informing those publics. And science literacy contributes to elements of critical thinking. Just to give you an idea of the aspects, the elements that make up scientific literacy, we have the nature of science, the interaction of science with society. As you can see, this forms the interaction is essential to developing it from the grassroots up. Okay, so how do we achieve scientific literacy? We're aiming this through scientific communication and engagement. There are, of course, challenges to this. So I love this cartoon because it just depicted the classic apples and oranges. Okay, the scientist has got apples and the public has got oranges. So they're both a fruit, but they're not quite the same thing. And that does seem to be a disconnect that's happening at the moment. Weingart, to go back to Weingart et al., they outline motives as the first challenge. So what are the motives of the researchers when developing their science? What are the motives of the publics when engaging with science? Okay. Does the public want to be scientifically literate? Right? These are all considerations that we have to take into account. The actors, we're talking about individual people, scientists particularly. Some actors do not want to engage in science for whatever reasons. This is going to depend on things like personal disposition, attitudes towards science, and expectations of science. Okay, so that, of course, actors, the individual people, is going to depend on them. And the other thing that when I read this, it kind of came to me as making a lot of sense, is that there is a tendency within modern society to polarize science. Okay? There's this idea that either science is completely accessible or entirely inaccessible. And the aim of science communication or science engagement is to fill this gray area that exists between these poles. So motives and actors, it's all, like I said, it's all going to depend on disposition, whereas polarization is probably the easiest challenge to overcome through science engagements. Through doing this, we will change attitudes, we will change expectations. And then on to the last part. So I think this is the question I get asked most. It's not necessarily what is it or why is it, but how. How do I do this? Okay. I'm going to run through several options, several ways of communicating science and engagement. It might not be an extensive list. You might have thought of something that I haven't thought of. So please, during the Q&A, please do put your hand up if you want to comment on something that you've experienced, that you've engaged in, that I haven't mentioned. I think one of the most important things I want to say about science engagement is that it's about communicating with your peers. Okay, so I can almost guarantee you that one of you knows someone who has some way engaged with the public through science communication or engagements. So ask yourself, have you ever given a research seminar or attended a research seminar and then talked about some of the ideas behind it? You're engaging with your peers, you're communicating your science. Have you ever attended a workshop? Either maybe you gave the workshop or you were a member of the workshop. What are workshops? Sharing of ideas, engaging in ideas with members of the public. Short courses are another example of this. Again, my list of examples is not necessarily extensive, and I'd like to invite you to give more examples at the end of the presentation. So your peers are one of your publics. Another form of engagement is community engagement. So here we're looking at the publics, very much high school students, educators, and parents. School workshops are a form of scientific engagement. If you know, National Science Week is held in August every year, just confirming that. And there are exhibitions, science exhibitions that are held as part of this for school children. School talks, going to your old high school and giving a talk, doesn't even have to be your old high school, it could be a local high school, and giving a presentation on mathematics at the high school and engaging with learners about why taking maths is so valuable to them. Also engaging with local science clubs. There are a lot of local science clubs set up across the country. And you can imagine how much they would love to have a researcher come and talk to them and inspire them to continue. An example of exhibitions is something that we as the Centre will be attending this year, Selfies Africa. It's a festival that's held every year in April in Makanda, and it's the country's national science festival. They have exhibitions, they have workshops, and they also have lectures given by researchers. And this year we're going to be exhibiting. So again, my email is on the start and the end. If you've got any ideas for SciFest, send them my way, because it's about this collaboration of knowledge. Okay. Another example of community engagement is a newsletter and a worksheet. This one is called the Science Spaza. Jive Media Africa are a media production consultant who specialize in science communication. And we as the Centre, along with several other researchers, have collaborated with them in the past to produce these newsletters. And these newsletters get printed, and they have worksheets as well. They get printed and they get sent to all these science clubs. Okay. Jive Media don't produce the content. The content is produced by mathematicians, statisticians, and other scientists. Okay. Jive Media are the intermediary who translate it for the public. Digital media is another example of science engagement. So if you've ever been on YouTube and watched a scientist talking about a mathematical or a mathematician or a statistician talking about a mathematical concept, you have engaged with science communication. Okay. So producing short videos for YouTube and other sites, podcasts for public consumption can also be very engaging. This video that I'm going to show you now features one of our Centre's researchers presenting their work, and this video was made with the view of communicating their research to the general public, so anyone could understand what their research was about. And just to let you know, this features our Deputy Director, Dr. Ashley Hutchinson. It's a minute and a half.
Ooh, we have to tolerate for a minute and a half.
How about the first minute?
I haven't even heard it.
My research falls under the very broad category called applied mathematics. In short, applied mathematics pertains to studies that use maths to solve real-world problems. I have personally been involved in developing mathematical models that are of relevance to industries such as mining, sugar, energy conservation, and fishing. However, none of these studies are going to have any relevance if we cannot address the big question. How are we further going to prevent the impacts of global warming on our Earth? Now, I look at one particular aspect of global warming, and that is its effects on ice sheets and ice shelves. Global warming causes instabilities in these ice shelves, which then further causes a rise in sea level. A rise in sea level leads to flooding and also the destruction of marine and terrestrial ecosystems that will lead to food shortages. In my research, I study these ice shelves in the framework called fluid mechanics modeling. In fluid mechanics modeling, we take ideas from maths and from physics and we integrate and combine them into one comprehensive study. If you are interested in studies of a multidisciplinary nature that have the potential to initiate global change, then why not come and join us?
Yeah!
Yay! Okay. So that's a series of videos that the Centre had produced. And all our researchers took part in this, and they all filmed minute-and-a-half videos. I'm not a mathematician. I don't know if I mentioned that earlier, I'm a linguist. But watching this video inspires me from, I'm very, very interested in environmental change on a personal level and global warming and climate change. And, you know, just for me, the thought that mathematics can somehow be contributing to this was exceptional. I absolutely love the idea. So you can imagine a matriculant who's trying to decide what to study because they don't know whether to study geology, for example. they're really good at maths, but they want to study climate change. There's that inspiration behind it that we are using science communication to engage with that student. Okay, so this is another example of media that is very, very popular. It doesn't have to be beautifully produced. You can, you know, if you've got a webcam, you can do this kind of thing at home. Okay. So digital media, video, and promotional video. I am going to show you another example of promotional video in a moment. I just want to talk now at certain amounts of length about social media. So the reason that social media is so important, it is ubiquitous. It is everywhere. Everyone is using social media. I don't think I know a person who doesn't use some form of social media. Even if they say things like, I never go on Facebook, but they've got a Facebook profile. Okay? So everyone in some way, shape, or form is using social media. If you watch YouTube videos, you're engaging with social media. It's ubiquitous, and very importantly, it's user-friendly. Okay? So my advice that I always give people when they say, I really want to, when mathematicians or scientists say to me, I really want to use social media to engage. The hard part, it's not that difficult, is in the actual setup. Setting up your profile and setting up your presence. From there on, it is incredibly easy to run. Okay, so it's just those initial stages that sometimes put people off. Once that's done, the actual running of it, all you're going to do is you're going to post when something interesting happens once in a while. Keeping your profile going is the easy part. Okay. Several studies have been done into scientific visibility and social media. Okay. In a study by Beck and Goldstein, I found this very interesting. In their study, they found that online tools, such as social media platforms, actually improved research efficiency. All right, so imagine that this can actually help you in creating a more streamlined research approach. Why? Because you're interacting with people and you're getting feedback from people. They found that it helps track and improve scientific metrics, so you're not just helping yourself, but you're helping other scientists at the same time. Something that almost seems obvious is that social media enhances your professional networking. So to go back to the benefits that this has for the researcher, creating an online profile will actually improve your chances of finding funding, finding work, finding research partners. And of course, there's a broadening that happens with social media. Your impacts are broader. This could be logistically. So someone who's doing research in South Africa could post something online, and someone who's in Norway could be accessing that via social media, and you're creating this broader impact across the globe. Okay. Another study that I wanted to talk about that I found quite interesting was a study by Giroux and his colleagues on the perception of the scientific selfie. Okay. So what they did is they took a group of everyday people and they showed them various social media photos. And some of these photos were of scientific fields without the scientist in the photo. Obviously, there was a balance of male and female scientists. And then they took selfies of scientists taking selfies in the field, so whether it was in their lab, in their science lab, wherever it might have been. They actually found that scientists who took selfies in the field were perceived as warmer and more trustworthy, yet no less competent than scientists who were just posting pictures of the field without themselves. A second finding was that participants who viewed selfies perceived less of a symbolic threat from scientists. So this is going back to that polarization idea. It's bridging the gap in that polarization. They perceived the competence no less than when they were viewing control images or science-only images. The other interesting find was that they viewed the subjects who view female scientists' selfies perceived science as less exclusively male. So there was an element of gender equality within the study. The findings overall suggests that selfies by STEM professionals, by mathematicians and scientists on social media can actually mitigate the negative attitudes towards science. Okay, so we're all going to take selfies. All right, so moving on from social media, one of the publics that I talked a little bit about was industry. Okay, I'd like to give you an example now of what I mean by that. So this is the logo from MISC South Africa 2020. MISC stands for the Mathematics in Industry Study Group. Okay. This is a study group that's held every year, and this is a study group where industry-related problems, I'll give you some examples now, are tackled by mathematical experts, lecturers, and researchers from South Africa and all over the world. And the kind of problems that they are solving are things like, why are the bees arriving late? And therefore jacaranda blossoms are blossoming late. I hope that we can see there the transfer between disciplines, okay, as well as the impact that this has on industry. Farmers, it's having a big impact on the farming industry. Another example, and this is what you can see in the picture, is the urban heat island, which is basically that cities are hotter than anywhere else. Urban areas are hotter than rural areas. But again, I'm not a mathematician. I'm explaining this in my own words. And that's why it always rains in the city. How can we mitigate this problem? By using green roofs. So mathematicians at the Mathematics and Industry Study Group were actually working on this problem for industry. Others included the sugarcane industry, and quite fascinatingly, exploding lakes in Rwanda. Okay, so this is an excellent example of engaging with the industry public. Just to go back to our to our digital media engagement, again, the centre, we had a short promotional video produced. It's 2 minutes long. I'm just going to show you the first minute to give you an idea. This is to give you an idea of what promotional videos can do for science engagement.
The Matteson Industry Study Group was started in 2004 by Professor David Mason. The main objective of the study group is to get problems from industry and to use mathematical methods to solve them.
The event takes place over 2 weeks. It's important for the academics, and it's also important for graduate students because it gives them the opportunity to solve real-life problems.
We have a huge variety of problems. This year we're tackling the bees and the blossom problem. We've also got another problem on Lake Kivu to do with turbulence mixing in the lake. We've got some very interesting problems from the sugar industry, which is again another industry that submits a problem every single year.
It has had a lot of impact on the academics. It's introduced new problems for the teaching, new problems for the research. It's also had an influence in that at least one person set up their own consultancy and are doing very well.
I think industries are the main people who can give us the problem, then mathematicians like us now sit together and try to solve it. So from that point of view, all these problems are represented by industry representatives. This event is important because we are training future generations.
This week has been great. The problems have been interesting. I think some of the most interesting problems we've had in any study group. It's very nice to also be at the University of Zululand. This is the first time that we've held the study group here. So it's been an amazing experience integrating with different researchers from this university and actually getting to know other parts of South Africa. So it's going really well.
I don't know if you saw any faces
No, we didn't see anybody with a camera.
I just think that's an excellent example of, you know, never say to yourself that I couldn't do this, because you genuinely can. This video is now available on the Censor's YouTube channel for anyone to access. Okay. Particularly, we want industry to access this so that we can have continued funding. It's giving a profile to the sponsors of the event, to the researchers themselves who are involved. Okay, so this is an excellent example of using digital media and social media to engage with various publics. And as you can see, what was said was in plain speak, so it was in language that anyone could understand. Okay. Just to move on to my second last, sorry. Another way of engaging with social communication engagement is competition. So FameLab is quite a famous competition that you might have heard of. It's run by the British Council. It's an international competition with local heats that are held at universities. It's a competition where researchers are asked to present their work in plain speak in 3 minutes. Okay? And again, if you're thinking to yourself, well, little old me, the winner in 2017, I wanted to show you the video, but just for time reasons, I don't have time. This is Chiamo Legoale. She's a geologist, and she won she's the international champion for 2017. So if you just Google, you can watch her video. If you just Google FameLab International Winner 2017, you can actually watch her video, and it gives you an idea of how you can communicate your science to all publics. And obviously it's a competition, so with the eventuality of perhaps winning a prize. Okay. Not everyone is a verbal conversationalist, so just to end off, I'd like to talk a little bit about online publications. So this is where, if you're more of a writer, you can engage with publics. So Quanta magazine is an international magazine that I use a lot for our Censor social media. I post a lot on our social media from Quanta. They produce popular science articles. Okay? So they take concepts such as machine learning and its impact on certain things within society, and it writes it in a manner that is available to the public in general. More approximately, closer to home, is the Conversation Africa. Okay. The Conversation Africa is an online publication, it's an online magazine. And what you do is you can actually submit to them, and you can say, I'd like to be involved, I'd like to write an article for you. They'll actually they'll actually put you together with an editor, and you work together with the editor to produce a piece of popular media in written form, and you actually get published under your own name. Okay, so they don't credit themselves, you're published on their websites, but they actually publish you under your name. And just to pick on someone again, the Deputy Director of our Censor, Dr. Ashley Hutchinson, has literally within the last few days published a piece entitled Mathematical Modeling, a Language That Explains the Real World. Okay. So she worked together with one of the editors, Natasha Joseph, to actually publish this piece on mathematics that was accessible to the general public. So another option there. Okay, so that's the end of the how-to. I'm just going to conclude just by reiterating certain things. Science communication needs to take the form of a dialogue in some form with various publics, whether it's between yourself and your peers, or yourself and your families, or yourself and educators. It's got to be a two-way thing. Okay, it's got to be a conversation, and that's why it's called communication. There are benefits and there are challenges. I hope that we've all seen that the benefits, there were certainly more benefits to it than there were challenges. Okay. And those challenges are, in my opinion, those that can be mitigated in some way by the benefits. We looked a lot at the importance of scientific literacy, and I hope that going away you see how scientific literacy impacts everyday life. Okay, not just scientists' lives. And then I've written here a vast array of methods that we looked at. Perhaps it wasn't as vast as you expected it to be, but it was certainly everything that I could think of. The methods to communicate science. And just to finish off, there's my email address if you want to get in touch with me, if you've got suggestions or any questions, please, regarding science communication and